প্ৰিয় শিক্ষাৰ্থীসকল, কৃষ্ণকান্ত সন্দিকৈ ৰাজ্যিক মুক্ত বিশ্ববিদ্যালয়ৰ বিদ্যায়তনিক দৃশ্য শ্ৰাব্য অনুষ্ঠানটিলৈ আপোনালোকক স্বাগতম জনাইছো। স্বয়ংপ্ৰভা DTH চেনেল 20ৰ যোগেদি শিক্ষাৰ্থীসকলৰ অধ্যয়ন কাৰ্য অধিক মনোগ্ৰাহী আৰু ফলপ্ৰসূ হোৱালৈ লক্ষ্য ৰাখি বিভিন্ন বিষয় সামৰি আমাৰ এই বিদ্যায়তনিক অনুষ্ঠানটি সজোৱা হৈছে। আহকচোন প্ৰিয় দৰ্শকসকল, আমাৰ আজিৰ খণ্ডটিৰ মাজলৈ আগবাঢ়ো।
Hello dear learners, welcome you all to today's audiovisual lectures of Unit 2 Binary Operation of the course Abstract Algebra and Discrete Mathematics of the program BA Mathematics second semesters. So today we will discuss Unit 2 Binary Operations. This is the third lecture of the course Abstract Algebra and Discrete Mathematics. So last two lectures we have already discussed relations and functions and their various properties, and we also discussed various examples of relations and functions. So today we will discuss Unit 2 Binary Operations. First we will define what is binary operations, then we discuss various properties of binary operations, and we will also discuss examples related to binary operations and their properties. So let us discuss this Unit 2. So now we start today's lecture on the topic binary operation. So in this lecture we will discuss first what is binary operation. So first we define binary operation. Then we discuss various properties of binary operation. So let us define what is binary operations. So we all know that there are four basic arithmetic operations: addition, subtraction, multiplication and division. So these four binary operations already we know. So to begin with the concept, we consider an example involving the basic arithmetic operations addition and multiplication of any two natural numbers. Suppose here m and n belongs to natural number. M and n any two natural numbers. So if we add two natural numbers, the result will be again a natural number. So m plus n belongs to n, and similarly their multiplication also belongs to n. So from these two operations, addition and multiplications, we observe the following results. Here you see at a time exactly two elements of n are possessed. There are two elements m and n, and resulting element is also an element of n. Here m plus n belongs to n, and m multiply n is also belongs to n. Suppose if we consider m is equal to 3, n is equal to 4, then 3 plus 4 belongs to n, and 3 into 4 it is 12 also belongs to n. So their results is also belongs to n. So now we define binary operations. Here a binary operation is star on a non-empty set S is a function from S cross S to S. Here star we define is a function. Already we discussed what is a function. So star is a function. Star is a function from S into S to S. Here this is a function, and this function is defined as star. So a binary operation is also a function from S cross S. If we consider any two elements from this set, here result will be A star B. This also belongs to S. So here image AB here belongs to S cross S under function star is defined this star AB is also defined as this way star AB. So star is a binary operation on set S. If A star B belongs to S, for all AB belongs to M. Here, if we consider any two elements from S cross S, the result will be A star B also belongs to S. So then we call that star is a binary operation on set S. If we consider any two elements from this set S cross S, the result will be A star B. So this will be suppose C, element C. So C also belongs to S. Then star will be a binary operation. Here you see star is just a symbol which may be addition, multiplication, subtraction, division. It may be matrix addition and matrix multiplication depending on the set which it is defined. So star is just a symbol and star represents these operations: addition, subtraction, multiplication, division, matrix addition, matrix multiplication. So here addition and subtraction, multiplication are binary operation n. If we consider one example, suppose addition and subtraction are binary operation on n, but subtraction is not a binary operation. Why? Why subtraction is not a binary operation? So addition and multiplication are binary operation on n natural number, but subtraction is not binary operation. To verify this result, we consider one example. Suppose we consider 5, 6 belongs to n cross n. Suppose from this set n cross n, from this set we consider one element 5, 6. Here subtraction is a binary operation. So subtraction is a binary operation on n. Subtraction is not a binary operation on n. To verify this result, we consider one example. 5, 6 belongs to n cross n, but 5 actually this is 3, 4. So 3 minus 4 is equal to minus 1. So this not belongs to this n. So this does not belong to n. So therefore subtraction is not binary operation. 3 minus 4 is equal to minus 1. So minus 1 does not belong to n. So subtraction is not a binary operation. So therefore this condition is not valid in case of subtraction. So now we observe this table. Here in this direction there are number system, and in this direction there are operations. There are 4 operations: addition, subtraction, multiplication and division. And here we consider this number system: natural number, set of integers, rational number, R, real number, C, complex number, Q. Subtract this non-zero rational number, this is non-zero real number. So for addition is binary operation on n, z, q, r, c, but addition is not binary operation on this set non-zero real number. And similarly non-zero, in case of non-zero real number, addition is not binary operation. Similarly subtraction is not binary operation on n, but subtraction is binary operation on z, q, r, c, but not binary operation on non-zero rational number and non-zero real numbers. Similarly multiplication is binary operation on n, z, q, r, c, non-zero rational number, also non-zero real number. And division is not binary operation on natural number, not integer z, not rational number, not real number, not complex number, but binary operation on this set of non-zero rational number and set of non-zero real numbers. These are the 4 binary operations on different number systems. So in case of some number system, these are binary system, and some number system, some operations are not binary operations. So here are some examples of binary operations. Already we discussed in the table. Addition is binary operation in n. Subtraction is not binary operation on n. Multiplication is binary operation on n. Addition is binary operation on z. Addition is not binary operation on set s. S is equal to z minus 0. This means set of non-zero integers. Non-zero integers. Subtraction is not binary operation on is a binary operation on z. So another example, S beta collection of real matrices. Matrix addition is not binary operation on S, so we cannot find sum of 2 cross 3 matrix and a 3 cross 4 matrix. Similarly, this is another example. If M be the collection of all M cross n real numbers, so matrix addition is binary operation on this set. Similarly, M be the all n cross n real matrices, then matrix multiplication is a binary operation on this matrix in this set. So addition and also multiplication is a binary operation on the set of C complex number. Now there is a formula. How can we find number of binary operations on a finite set? So this is a standard formula. If we consider 2 sets of finite sets, number of elements of M is M, number of elements of B is N, the number of functions, this number of functions may be binary, number of binary operations from A cross B is n to the power M. Suppose number of elements of a set is 3, number of elements of B is 2, the number of binary operations will be is equal to 2 to the power 3 means 8. So there are 8 binary operations on from A to B. Next there is a operation table, or this is also called composition table. If S is a finite set and number of elements of S be small, then we can construct a table known as operational composition table. So in the next discussion of some questions we will discuss a composition table. We give an example of a composition table. How can we find whether a operation is binary operation or not with the help of composition? So now we discuss various properties of a binary operation. So first properties is commutative property. Any operation star defined on a non-empty set S is said to be commutative if this condition is satisfied. Means A star B is equal to B star A. For all elements AB belongs to the given set. So next property is associative property. So any binary operation star defined on a set S is said to be satisfied the associative property if this condition is satisfied. bracket A star B star C is equal to A star B bracket B star C for all elements A, B, C belongs to the given set S. The next property is existence of identity element. Existence of identity element. Suppose we consider a set S. S be a non-empty set equipped with a binary operation star. An element E belongs to S is called an identity element for if A star E is equal to A is equal to E star E. For all A belongs to the given set S. If this condition is satisfied, then E is called the identity element of the set S under the binary operation star. The identity element of a binary operation, if it exists, is unique. There is only one binary identity element in a binary operation on a set. Here, now we consider some examples. How can we find identity element of a binary operation on a set? Suppose multiplication, we know multiplication is a binary operation on n. Then there exists 1 belongs to n such that A into 1, here A into 1 is equal to A is equal to 1 into A. For any element belongs to n. Suppose 3, suppose. So 3 into 1 is equal to 3. So 1 into 3. For any element, this condition is satisfied. Suppose 10 into 1 is equal to 10 is equal to 1 into 10. So for any elements of natural number, if we consider 1, then this condition is satisfied. So therefore 1 is an identity element of a binary operation multiplication on the set n natural number, set of natural numbers. So 1 is the identity element of for multiplication in n. Similarly, we consider another example 2, 3 and 4. Here 2 you see addition is binary operation on n. So there exists 0 belongs to z such that A plus 0 is equal to A plus 0 plus A for all A belongs to z. Here 3 plus 0 is equal to 3 is equal to 0 plus 3. For any set of integers, any element from the set of integers, so this condition is satisfied. So therefore 0 will be the identity element for addition in Z. So 0 is also called additive identity. So addition is binary operation on n, but there does not exist identity element for addition in n, because for any element of from the set of integers, this condition is not satisfied for addition. Similarly, matrix multiplication is a binary operation on this set M, set of all m cross n matrices. The set of all m cross matrices, the m cross n null matrix 0 is the identity element for matrix addition. So for matrix multiplication, set null matrix is the identity element for matrix addition on this set M, set of all m cross n real numbers. So next property is existence of inverse of an element. Existence of inverse. So let S be a non-empty set equipped with a binary operation star and with identity element E. Star is a binary operation on set S and E is the identity element. Then an element B belongs to S is called an inverse element of A under star if this condition is satisfied. A star B is equal to E and B star A. Then B is the inverse of A. if inverse of an element under a binary operation, if it exists, is a unique. So there is only one inverse element of a binary operation. So now we discuss examples of an inverse element of a binary operation. So we know that binary multiplication is a binary operation on n, and 1 belongs to n is the identity element for multiplication, but no element of A except 1 possesses inverse under multiplication on n. No element of n except 1 possesses inverse under multiplication of n. Similarly, addition is a binary operation on Z, and 0 is the identity element for addition. So for every A belongs to A, there exists minus A belongs to Z, such that this condition is satisfied for any element of Z. Then minus A is the inverse of A under addition. Suppose 3 is a element of Z, and minus 3 is also element of Z. Then 3 plus minus 3 is equal to 0. Similarly, minus 3 plus 3 is equal to 0. So this condition is satisfied for binary operation addition, for binary operation addition on Z. So therefore minus 3 is the inverse of 3. Inverse of 3. So this minus 3 is also called additive inverse, because operation is addition. So learner can also follow these books for better understanding of this chapter. So these are some reference books. So with the help of this reference, you can understand this concept with the some various examples from this book you can consider. So now we discuss some questions. So example 1, your operation star is defined by this: A star B is equal to A minus B plus 10. We have to find whether this operation is binary or not. So here A comma B belongs to Z. So Z is a set of integers. So clearly A minus B plus 10 also belongs to Z, because subtraction of any two numbers also belongs to Z, and addition is also binary operation on Z. So therefore A minus B plus 10 belongs to Z for all AB belongs to Z. So therefore obviously A star B is equal to A minus B plus 10. So clearly A minus B plus 10 belongs to Z. So obviously A star B belongs to Z for any elements of AB belongs to Z. So star is a binary operation on Z. So another example, here operation star is defined by A star B is equal to AB by 5. So now we find whether star is binary operation or not on Q. Q is the set of rational numbers. So since AB belongs to Q, obviously their multiplication also belongs to Q. So product of any two rational number is also a rational number. So and AB by 5 also belongs to Q, set of rational number. So here A star B is equal to AB by 5. So therefore obviously A star B belongs to Q for any elements of AB belongs to Q. So A star is a binary operation on Q. You can take any two numbers, suppose 3, 4 belongs to Q. Obviously 3 into 4, 12 belongs to Q, and 12 by 5 also belongs to Q. So this way we can prove that this A star B is equal to AB by 5 is a binary operation on. Next, example 3. Here we have to find whether multiplication is a binary operation on the set. This set -1, the set consisting the elements -1, 0, 1. So now we prove this result with the help of a composition table or operation table. Here, here you see the elements of the set we put in horizontally and vertically, -1, 0, 1, and vertically -1, 0, 1. Now here this cell, the outcome of these results, you see -1 into 1, -1 into -1 is 1, we put here, -1 to 0, 0, -1 into 1, -1, 0 into -1, 0, 0 into 0, 0, 0 into 1, 0, 1 into -1, -1, 1 into 0, 0, 1 into 1, 1. You see all these 9 elements also belongs to this set. Each of the 9 entries also belongs to E. So since all the elements belongs to this set, so therefore multiplication is a binary operation on this set. If the set consisting a small number of elements, then we can apply this table, which is called operation table or composition table. Next example, example 4. Here star is a binary operation defined by this A star B is equal to A minus B plus 5. So now we check this operation for commutative, whether it is commutative or not. We check commutative property for this result. So we have this result A star B is equal to A minus B plus 5. So obviously B star A is also B minus A plus 5 for all A B belongs to set. You see this A star B not is equal to B star A. So clearly this A star B not is equal to B star A. For commutative, the result is A star B is equal to B star A for all elements of AB for any set. So here A star B not is equal to B star A, so star is not commutative. Here star is defined by this same result, actually same for same result of example 4. The operation is same. A star B is equal to A minus B plus 5. So now we check associative property for this binary operation. So for associative property, already we define associative property. For associative property, we have to prove these results. If this result is satisfied, then star will be associative. So first we check left hand side part. Bracket A star B is equal to bracket A star B star C is equal to this. Here A star B is defined by A minus B plus 5. So in place of this we put this result. Then star C. Again for these two elements, again we apply these results. So in this case now A will be this element A minus B plus 5 and B will be C. So accordingly we put these elements in this result. So A minus bracket A minus B plus 5 minus C plus C. So a minus b minus c plus 10. After simplification we get this result. Now we find right hand side part. So a star bracket b star c a star. So we apply this result. Here a means b and b means c. So accordingly we put this result b minus c plus 5. So again we apply this result. Then we get here a means a and b means this result b minus c plus 5. So we put here. After simplification we get this. You see the result of left hand side and result of right hand side is not equal. So therefore bracket a star b star c not is equal to a star bracket b star c. So the associative result is not satisfied by this binary operation. So hope this lecture will benefit all of you. So with this we end today's lecture. Thank you all.
ইমান সময় আমি স্বয়ংপ্ৰভা DTH চেনেল 20 যোগে সম্প্ৰচাৰিত কৃষ্ণকান্ত সন্দিকৈ ৰাজ্যিক মুক্ত বিশ্ববিদ্যালয়ৰ বিদ্যায়তনিক অনুষ্ঠানটিৰ আজিৰ খণ্ডটি উপভোগ কৰিলো। এই বিদ্যায়তনিক অনুষ্ঠানটিৰ জৰিয়তে শিক্ষাৰ্থীসকল নিশ্চয়কৈ ভালেখিনি উপকৃত হৈছে। পুনৰ আন এটি বিষয় লৈ আমি আপোনালোকৰ মাজলৈ আহিম। নমস্কাৰ।